Right, we're now on how to distill, and this is now my wee distillery in here. As you can see, it's a bit cramped and I'm fighting with the laundry and my tools, etc. like that. But it just shows you how versatile this still actually is. You don't need a big space. I wish I did have a bigger space with shelves and stuff like that, but I managed to get by. So there's my still, which I'll explain in a few minutes. And this is my all my equipment, ingredients, etc, etc, my final products. So this is CJ's Distillery. So what we've done is I've made the wash, it fermented, I got the right specific gravity from it, and then I cleared it, and that process is in the other video. So once I cleared it, and then I put it into my still. Now the still's made up of two parts. The big silver bit is like a kettle, it's like a big zip really, and the condenser is the copper bit there. There's tubes that come out of it as well, and that's for your water flow regulators. So inside the stainless steel kettle, or I turn it on, I turned this on at 10 past 10, and it takes approximately 5 hours for the whole process to finish. So I've got a wee bit longer to go. Obviously you're not going to be here till 10 past 3, but I need to be. So the water inside there is at boiling point. It's going to continues boiling for the whole process, for the whole 4.5–5 hours. It will continue boiling. Inside the condenser there's what's called saddles, because you want the vapours, you want the biggest mass amount of area that you can possibly get. So they use stainless steel saddles. I've got one spare here somewhere. No, here it's here. So that's your saddles, and this condenser is just full of saddles up to about this mark, and then it's full of copper saddles, bits of copper. And what that does is it creates even more area mass for the vapours to get trapped in. And so with the process, it's at boiling point, and the vapours come up the condenser, and the water and other vapours that you don't really want, they're the heavier stuff. So once it's condensed, they'll drop back down again, and the whole process just keeps going for the 5 hours. And in here where the water, I'll show you in a minute, where the water is, the alcohol vapour hits the cold water and then turns into alcohol liquid. And alcohol liquid comes down here and out of this bit here, and this is, you can just see it dripping away there. So the cold, to get this, although it's boiling point in here, you don't want it boiling. You can maintain a temperature in this area of between 55 and 65 degrees centigrade. Now I'm touching, see that, 57. So with this water regulator, it's just a wee needle valve, allows the cold water to come into the condenser through this. This is a tube inside a tube, comes in here and hits another copper. It goes round in a spiral copper pipe, hits all these copper saddles inside here, and then that temperature will allow the heavy liquids to drop, and it will allow the alcohol vapour to turn into alcohol liquid, and that then falls down in there. So I've got this water, the water comes in here, and then the hot water goes out there. Quite simple, just a continuing. So I've now got to regulate this. I try and keep it at 55 to 65. It's at 57.4, which is alright. I can reduce it. I've been having it at 55 for a wee while now. So it's just a matter of turning your needle valve up just a bar here, and that then should reduce. Yeah, it's dropping a wee bit now, 59, 67, but there we go. So it's going down. Now the reason that you have this temperature at 55 is good. If you have it lower than 55, you're possibly not going to get it. The vapours won't come up. They'll just stay in there. So you want the temperature to just be at 55. More than 65, you get more vapour coming out. It actually distills faster, but your end result is not as good. So out of the 31 litres of wash, I'll collect approximately around about 3.5 litres of 90 to 93% proof coming out of there. The first couple of hours of this process, it works very quickly actually. The first couple of hours I've now got, I don't know if you can see that, just over 2.7 litres I've captured, and that's good. Now to get to the 3.5, it takes another couple of hours, and then it slows down and slows down. This will, any alcohol inside the kettle, it'll come out. It captures about 98% of the alcohol through this process. As long as I maintain these temperatures, and as long as everything is working well, and that's why I've got to stay near here. Unbelievable, for 5 hours I've got to be near this, because if somebody uses the toilet or the dishwasher or whatever else it is, and it affects the water flow, it affects the temperature. So I've just got to be very careful, mindful. I can't walk away from it really, because it is highly explosive, and things can happen. So the process that I've just explained, and it's all the technical names. So the water comes up, and it being lighter, the alcohol being lighter than water, it rises to the top, drops down, the water and all the other stuff that you don't want drops back down, and the whole process keeps going round and round and round, and that's called refluxing. So the saddles, like I said in the column, provide a large surface area to maximise the contact between the liquid and the vapour flows. And then this system here it's been technically engineered to get the maximum amount of alcohol that you can. This isn't the only system there is. There's multiple different types, but this one gets you approximately 98% of the alcohol that you've distilled, of your wash. So if there's any alcohol in there, it'll get it and bring it out. So with the 6 kilograms of sugar that I used in the initial wash and the yeast, like I said, I'll get approximately 3.2 to 3.5 litres of 93% ABV alcohol. And then when I water that down, I'll get approximately 7 to 8 litres of 40%, which is not too bad. That's just 6 kilograms of sugar and a bit of yeast. So what's in this distillant? So it's in here is 93% alcohol, and there's about 6.9% of water, and the 0.1% that's left is a mixture of compounds called congeners, and they're responsible for the good and bad flavours. So that's basically it. So I've now got to sit back, and I sit and catch up with Facebook and play games and stuff like that for the next 2-3 hours. And then when I've finished this process, I'll then show you how I've then got to put it through a filtration process. I've got to dilute it, so there's